Okay, guys, on to 5.3, inverse functions. So remember, this is in Unit 2 because we're still dealing with derivatives and their rules. So we're going to look at another rule today. Just going back to what an inverse function is, though, if you can take f of g of x, so composition of functions, and g of f of x, and in both cases they equal x, then g is the inverse of f. So one way to think about it is like f undoes what has been done by g and vice versa. So if you're asked to verify that these functions are inverses, what you need to do is you need to find f of g of x and g of f of x. We should get x, as we just mentioned. So f of g of x, work inside out, so take g, sub it in to the f function. The square root undoes the square. Don't forget to keep that in parentheses. You end up with 9 minus 9 plus x, which is x. So they said verify. We know this has to work. So we're really just checking. The next one would be g of f of x. So now we're going to take f and put it into the g function. So it's going to be, well, we can write it out this way. G of f, so 9 minus x squared. We then take 9 minus x squared and sub it into g. So we're going to have 9 minus 9 minus x squared. If we distribute the negative, we have 9 minus 9 plus x squared. The square root of x squared is x, and we're good. Okay, so that's how you verify them. Over on the left too, if you wanted to see an extra step here, it could have been f, and then you could have replaced g with what it was before we went on, if that was a little confusing. If you graph them, now one thing to note, do you guys see that when the first part, they have x greater than or equal to 0, so we're only dealing with positive x's. So if we sub a 0 in, actually, you know what, let's change this to count by 2's. So if we sub a 0 into the function f, so over here, I'm going to get 9 out. So let's, if we count by 2's, 2, 4, 6, 8, here's 9. And then another quick number I can use is if x is 3, then the answer is 0. So if I'm here, so can you see that this right here is going to be the function f of x? They gave me a restricted domain. The square root function, which is g, has no restricted domain. We're going to go ahead and graph that. If x is 9, we're going to get 0 out. So 2, 4, 6, 8, 9. Also, if we let x be 0, we'll get 3 out. And you have this function. And this is g. Okay, we're claiming that they're inverses. Do you guys see, do you remember this? That to be inverses, that g is going to be reflection of f over, and this is the part I don't know if you remember, it's over the line y equals x. So if you look here at this line of reflection, this is the line y equals x. So I'm asking you to graph it. This is what I'm hoping you notice. Do you see that this, if you turn your paper, you can see that this gap is the same as this gap. This is the same as this. So they're a reflection. Okay, so that's what we're trying to notice, that g is the reflection of f over the line y equals x. Okay, so just recapping with you a little bit about inverses. Okay, so I gave you the two inverses, but what if we have to find them? Well, what you would do is you would replace f of x with y. You would go ahead and swap x and y, and then you would solve for your new y. So if y is by itself, you're going to embed it, and then you're going to flip it and solve for it. After that, we're going to write our inverse as f to the negative 1. Okay, 2, find the inverses of a power function and then graph f and f inverse. So to find this inverse, it says replace f of x with y. It then says to swap them. Now you're going to go ahead and solve for y. So we're going to divide by 4. Then we're going to take the square root. So y is going to be plus or minus 1/2 root x. Notice over here that we have a restricted domain of x greater than, or x less than or equal to 0. I want to show you how this works. If you make a table with the original function, x less than or equal to 0. So let's choose like 0, -1, -2, -3. So if I sub these into this f function, if I sub a 0 in, I'm going to get 0, a -1 is 4, a -2 is 16, and a -3 is 36. Notice that all of my outputs here are positive, all my inputs are negative. Okay, the outputs are all positive because look at, I'm always squaring, and I should say positive or 0. If you make a table of F inverse, which we just found, and you know what, let me go back, I never finished. We're going to write F inverse, and we're still going to fill that in. We're going to wait a second. So if I make this table, okay, now let's pick some X values. So the thing that we're hung up on right now is this has a plus or minus, and we only want to keep one or the other. So if I look at this function, right, I can only choose positive x's. Do you guys see that? Because I'm taking the square root. So let me start by picking 0. So I don't know what to do with this plus or minus yet. I'm still debating, okay? But if I put a 0 in, I'm going to get a 0 out. If I put a 4 in, what do I get out? If I put a 4 in, I'm going to get the square root of 4. The square root of 4 is 2, and 2 times a half is 1. So we know that this is 1, and I'm debating again what to put in front of it because there's a plus or minus, and I can only keep one of them. So what's going to happen is, do you guys notice 0, 0, 0, 0? Now look, the output became the input. So this input becomes the output, and that's how I'll know that I'll keep a negative. If I put a 16, -2, and a 36 is -3. So now I can go back and say, okay, here's how we'll know this. If I restrict the input of my function, because I'm inherently switching x and y, the input of my function becomes the output of my inverse. So if the input is all negative, I need these outputs to be all negative, and that's how I'll know to have a -1/2 times root x. Okay, going on, find the domain and range of both f and f inverse. What do you notice? Okay, let's start off with our f. So the f, the domain, they listed it right here. We can go back up and show that. The domain of f is x less than or equal to 0. So the domain is less than, oh, you know what, we don't want this. It's less than or equal to 0. The range. Now look at the range. If I am always going to square something, it's always going to be 0 or positive. So the range is going to be 0 to infinity. Now if I look at the inverse, what's the domain of the inverse? You can look over here. The domain of the inverse, it looks like, where's our inverse function? Our inverse function is right here. You can only sub 0 or positives in there. So it's going to be 0 or positives. And then the range, look at what we have again. We have a negative in front of it, and this will be 0 or positives. So we're looking at negative answers up to 0. And do you guys notice this whole switcheroo thing? The domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. Okay, let's go on. We're still reviewing inverses. We haven't even gotten to calc yet. So the inverse of a function is also a function. Okay, we'll have to say this slowly. So the inverse of a function is also a function if and only if no horizontal line intersects the graph more than once. So for instance, look at this. If I have this right here, this passes the vertical line test. So this is an Algebra 1 topic. Do you see how it passes the vertical line test? So this is a function itself. If it passes the horizontal line test, then the inverse is always a function, is also a function. If you look over here at this one, and let's use a different color. If I graph this, we're in Algebra 1. Is this itself a function? Does it pass the vertical line test? Yes. However, it does not pass the horizontal. So if I was looking at this graph of a function, I would say, yes, this is a function. However, its inverse is not. Okay, if you look back here, guys, look at the one I gave you. In both of these cases, they restricted the domain. So they weren't looking at a whole parabola. They were only looking at half of it. Remember, we only looked at this half? This passed the horizontal line test. So the inverse, which is this, is also a function. Okay, if you need me to go over that more in class, then we can totally do that. Okay, going on, strictly monotonic. What does mono mean? It means one. So if a function is always going in one direction, then it's going to be 1 to 1, and it will have an inverse. So if they ask you to show something is strictly monotonic, we want to show that the function is always increasing or always decreasing. So monotonic, going in one direction, meaning always going up, it could wave, right? Or always going down. What happens is if a function is always going up and it can't come back down, then it can't fail the horizontal line test. Like look at this one. This function is not monotonic. It goes down then up, therefore does not pass the horizontal line test. Okay, so that's why we're looking at this. Show that f is strictly monotonic and therefore has an inverse on its interval. Okay, to do this, let's sketch the graph. I bet you guys know what this graph looks like. This is going to be the absolute value graph shifted 2 to the left. So it looks like this. Okay, looks like a little more of a V-type, but something like that. Let's go ahead and practice making a piecewise out of this. I only want the interval right here that is going from -2 to 0. So I really don't care about the other part, but we're going to practice it anyway. I want you to remember how to write a piecewise. So anytime that I'm looking in here, when is this equal to 0? It's when x is -2. So we're going to say that's going to be our breakpoint. And I don't care if you put the greater or if you put the equal sign on the top or the bottom one. I'm just going to put it on the top one. Okay, so I have x less than -2 here. So -2 is what makes the stuff inside the absolute value be 0. Now let's look right here. Anytime I have something bigger than -2, think -1, 1, 5, this is always positive and the absolute values are not needed. If I go over to my graph, x plus 2 is this piece right here. Okay, now let's look at the other part. Every time I have an x less than -2, -1, 0, or I'm sorry, -3, -4, -5, anytime x is any of those numbers less than -2, this whole thing is guaranteed to be negative. The absolute values force it positive. Another way to force something negative positive is by putting a negative in front of it. Like I said, if I replace x with -3 here, I'm going to get a -1. The negative makes it positive. Okay, so then this other piece on the left is -x plus 2, this piece right here. Do you guys see why we have different slopes? On the left here, the slope is -1. On the right, the slope is 1. So the left derivative is different from the right derivative. Okay, all of that we didn't need to answer it. I wanted to practice writing the piecewise. How are we showing that strictly monotonic? I'm only looking at -2 to infinity. So guys, I am only looking at -2 to infinity, which is this top line. What is f prime on that top line? F prime, what is the slope of x plus 2? What's the derivative? It's just 1 from -2 to infinity. What can we say about this? We can say f prime is always positive. Therefore, this is shorthand for therefore, f is always increasing. I'm running out of room. Okay, this indicates, what do we know about a function that's always increasing? This indicates that f is 1 to 1 and therefore has an inverse on -2 infinity. Okay, so backing up, they say strictly monotonic. We think our derivative always has to be positive or always negative. We can't really take the derivative of a absolute value, so we made it into a piecewise. We only want -2 to infinity, so I only want this piece, and that derivative is 1. That's always positive, always. So f is always increasing, and we're good to go. Okay, recapping. In inverse relationship, interchanges x and y values. Try to fill these in before me. The graph of the inverse, what does it reflect over, guys? We saw one. Reflects over y equals x. It's a reflection of the graph of the function over y equals x. The domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. Okay, and then the last two statements also. In the bottom, so now we're getting into differentiability. If f is continuous, then the inverse is continuous on its domain. If f is increasing on the domain, so is the inverse. Same with decreasing. Then if f is differentiable at c and the derivative is not equal to 0, then f inverse is also differentiable at C. Okay, now on to some calculus. Look at, I gave you a function right here. I gave you its inverse right here. Notice a couple things. They found the inverse for us, right? Notice the restricted domain here. Also, 1, 1/2 becomes 1/2 1 because remember they switch spots. So find the domains and ranges of f and f inverse. Okay, so let's go ahead and do that. Well, don't we know the domain if we're looking at f? Don't we know the domain of f? They tell us right here, x greater than or equal to 0. If we know the domain of f, doesn't that mean we know the range of f inverse? Remember they switch. What is the range of f? Okay, we got to think through this. The range of f means what is the outputs of this function? Okay, think about it. If x is, look at the smallest x can be is 0. If x is 0, isn't this 1/1, which is 1? Okay, so I know I have a 1. Now let's look at something else. X gets huge. As x gets huge, I'm going to have 1 over a huge number. Doesn't that go to 0? So I'm capping out at 1 and I'm bottoming out at 0. So that will give me a range if I'm capping out at 1 and bottoming out at 0, like this. Now when we subbed 0 in, I got a 1 out, so I'm including 1. I'll never get to 0 though, because remember this is like a limit. As x gets huge, I'm going to have 1 over a huge number. It approaches 0, but never hits it exactly. Because I know that range, I know that this domain then has to be 0 to 1 inclusive of 1. Okay, sketching, you guys know that we switch points. I'm going to skip that part. If you want to graph them on your calculator, go ahead. Now it says complete the chart by finding the slopes of the graph in f and f inverse at their indicated points. Well, what does slope mean, guys? Doesn't that mean to take the derivative? So if f is 1 plus x squared to the negative 1, I'm going to go ahead and take its derivative. This is chain rule. Here's the inside. So what I'm going to do is I'm going to bring down the negative, write 1 plus x squared to the negative 2, and then the derivative of the inside is 2x. So this is going to give me negative 2x over 1 plus x squared squared. They asked me to do the chart. Well, the point of the function, if you look up here, they gave you was 1, 1/2. So we are going to go ahead and write 1, 1/2. Then they said find the slope, which we know is the derivative of the function. So look at this box, it's the derivative of the function at that point. So what I really want is the derivative, we want the derivative at 1, which is negative 2 over 1 plus 1 squared, which is negative 2 over 4, which is negative 1/2. Okay, so here we want negative 1/2. We're trying to figure something out, right? Like, why would we make a table just for fun? So let's keep going. Now we want to find the next function, which is the inverse. Okay, so my plan is to take this derivative. Oh, look, we have quotient rule, we have chain rule, but because there's only one term in the bottom, we can rewrite this. And remember, we want to write it all to the half. So looking at this, x goes into 1, and we get 1 over x. X goes into x, and we get 1, all to the half. That's f inverse. So now if I take f inverse and take its derivative, it's going to be chain rule. Look at, this is the inside stuff. So I'm going to bring the half down. I'm going to get, and you know what? Actually, let's rewrite it like this. Let's write it as x to the negative 1 minus 1 to the half so that we can take the derivative easier. So again, I'm bringing the half down. I'm bringing the half down in front. I'm going to copy this to the negative half, and then I'm going to take this derivative. Okay, so let's do it. We brought the half down. I'm going to copy this to the negative half, and then the derivative of this inside stuff is going to be negative x to the negative 2, and the derivative of 1 is 0. How about we rewrite this? This looks really bad. Okay, so the 2 in front right here goes on the bottom, because this is all to the negative half, that's the square root, we're going to write it on the bottom, and that's 1 over x. So it's going to be the square root of 1 over x minus 1. Then we have this right here, which is a negative 1 over x squared. I'm going to put the negative on the top and write x squared down here. Okay, keep going. What point now? Well, look up here, and they tell us the point 1/2 1. So what I'm going to do is go over here and write 1/2 1. Remember, they just switched. These just switched positions. So now I want the derivative, which is the slope of the inverse, at 1/2. So it's going to be this. And I'm going to replace every x with 1/2. When I get down here, if I replace this x with a half, this becomes a 2. So now I'm going to get 2 minus 1. And you know what? That square root got a little long. Let me fix that. Okay, now I'm at this part. X is a half, so if I square a half, I'm going to get a 4th. I forgot to write that 1 in there. Okay, now let's see what we have. In the numerator, we have a negative 1. In the bottom, in the denominator, I'm going to have a 2 times 1, which is 2. So 2 times a 4th is a half, giving me negative 2 as my answer. Okay, so what did you notice? So let's back up and see what we did. We had a function with an ordered pair. Because the inverse, all we have to do is switch that, because remember the x becomes the y. That's how we got these 2 points. We then took this derivative to get the slope at this point and got negative half. We then took the derivative, which is the slope at this point, to get negative 2. So what do you guys notice? Do you notice that these guys are reciprocals? Okay, and we're going to use that to do the next example, because what happens is they gave us this inverse, right? But what if they gave us a crazy function and we can't find the inverse? Well, then we're going to use this shortcut here. Okay, so I want you to do this chart when you're doing your homework on these problems. I typed up these directions for you, and I'm going to walk through how to do this. Okay, so look right here. Find the derivative of the inverse. But all they gave me was f. So if I go ahead and try to find the inverse, remember this is really y. You're supposed to switch them. So it should look like this. Now if you guys try solving this for y, you can't, because you have a y to the 5th and y cubed. If I can't solve for y, what happens is I can't find the inverse. Well, think about what they're asking you to do. They're asking you right here to find the derivative of the inverse. Well, how am I supposed to do that if I can't even find the inverse to begin with? So here's the shortcut that we're going to take. Okay, this is pretty cool how this works out. They ask you up here for the derivative of the inverse when x is negative 2. So in the inverse, x is negative 2. So I'm going to come to the inverse, and x is negative 2. But if negative 2 is the input of the inverse, it's the output of the function. I'm doing this because I do have access to the function. The function is right here. So I'm going to let negative 2 be the output of the function. I'm going to bring the negative 2 to the other side. Now this doesn't factor. I'm going to ask that you guys use your calculator. You can do this on your own. Let this be y1. Find out where it crosses the x-axis, and I'm going to go ahead and give you the answer, but you guys try it on your own. If you need help, you can ask in class. So what we just did is we have the output of the function is negative 2, and we wrote it here. Now I know the input of my function, which is all I have access to, is negative 1. So now I can write negative 1 right here. Remember, the inverse and the function switch domain and range. So then if the input of the function is negative 1, the output of the inverse is negative 1. What did they ask for? Let's go back up and look. They asked for the derivative of the inverse at negative 2. So let's highlight that, what box you think that occurs in. Find the derivative of the inverse at negative 2, and it should be this. Slope, which is derivative of the inverse. I need to get here. What happens is you start here, and you're going to cycle through till you get here. So we started with an input of negative 2 because they gave it to us here. That then became the output, which we then did this work to find this input. Now, can I find the derivative of the function to get this piece? Sure. We know that f is given to us above, so this derivative is 10x to the fourth plus 3x squared. So this box, though, is the derivative at -1. So now I'm going to sub a -1 in. Which is 13. That's 13, but I wanted this highlighted thing to begin with. I couldn't do it because I couldn't find the derivative of the inverse. But remember what we discovered up here, that these answers are reciprocals. A common mistake is to do opposite reciprocals. Don't do that. You just want reciprocals. So then this is 1/13, and that's your answer. This is pretty cool. If you read this right here, we found the slope of the inverse, and we have no idea what the inverse is. Okay, so it helps us to get around that. Okay, guys, almost done. Looking at the next one. Same kind of problem. They ask you for the derivative of the inverse. So what I need you to do is have this table memorized. It's function, inverse, point slope. I think of, remember point slope form? So if you think of it that way, that'll help you remember that. Okay, they asked for, remember we want this. Well, you know what, let me put another line in here. You want this right here. They tell you up above that x is 1. So the f of the inverse. So f of the inverse is 1. The input of the inverse becomes the output of the function. So 1 equals the output of my function. If you, okay, just thinking about this, guys, look at your unit circle. Cosine is the x. When is the x 1? Right here at 0 radians. So when x is 0. So if the input is a 0 here, then it's also the output. Now writing it as the output over here, we really don't need, but it's nice to see the flip-flop. Now this, remember I don't know how to do this, but can I find the slope of f? Sure. The slope of f is the derivative of f. The derivative of f, this is chain rule. You guys see the inside here. So the derivative of cosine is negative sine, and the derivative of the inside is 2. So the derivative is negative 2 sine of 2x. But I don't want the derivative in general. I want the derivative when x is 0. So then I say f prime of 0 is negative 2 sine of 0. Sine of 0, here's 0, my unit circle, that's 0. Now remember the relationship here. Aren't you supposed to take reciprocals? So if I have 0 in the numerator on the left, this now becomes does not exist. Okay, so that wraps up the procedure. Remember, I have it typed up for you here if you need to go back and look at it, but now that you have the video, I guess you could just listen to it too. Okay, the last couple really are just questions that come up on the homework. We're really done with the lesson. The biggest thing was looking at those last 2 examples of how to get the derivative of the inverse when you don't have the inverse. If you want to wait to look at these to see if you need help with them, not a bad idea. I just want to remind you that those circles mean composition of functions, so it really looks like this. G of the inverse of G composed with the inverse of F, like this. Work inside out. Okay, so right here, oh, look at, they're asking for the inverse of F, but I don't have it. Here's F. So we actually have to find the inverse of F. So let's do that off to the side down here a little bit. Okay, so let's find the inverse of F. So if y is 1/8 x minus 3, the inverse is found by switching the variables and solving for y. Okay, at this point, multiply both sides by 8. So y is 8x plus 24. So the inverse of f is 8x plus 24. So look at what we're doing up above. We're trying to find the inverse at -3. So I'm going to take this and sub a -3 in. So it's going to be 8 -3 plus 24 in here. Okay, so this is inverse. So we said 8 -3 plus 24, which gives you a 0. Now look here, Oh, bad news, they did not give us G inverse either, so we got to find that below. Okay, let's go ahead and find G inverse. If G is x cubed, we replace that with a y, we do a little switcheroo, and y is the cube root of x. So G inverse is the cube root of x. So now if I come back here, I'm going to take the cube root of 0, which is 0. Okay, so that's all they meant there. Again, if you caught on, you really don't have to listen to B if you want to try the homework on your own. Okay, composition with the circle, let's write it twice. G inverse of negative 4. We have to find G inverse of negative 4. Okay, look at G inverse down here, cube root of x. So we're going to find the cube root of negative 4. So G inverse cube root of negative 4. Now, I don't know what that is. And remember, let me write this off to the side. G inverse is the cube root of x. So if I'm going to do the same iteration, I'm now going to replace this x with this stuff. So now I get, this is going to look weird, the cube root of the cube root of negative 4. Well, remember the cube root means 1/3 and this means 1/3. So this is really 1/9, which is the 9th root. Okay, again, the biggest point was I need you guys, the book is going to do it differently. We have found that this method works the best when you're finding the derivative of the inverse. I'm going to ask that you use this method in your homework for 5.3. Okay, kids, see you later.